Hello everyone, welcome to today's session. So this will be the last interactive session before the exams. So today, if you have any questions from the remainder of the course, we can also discuss those, or you can also go through any doubts that you have regarding the last week. So let us wait for a few more minutes and then we can start. Yeah, hi. Yeah, you can start it today.
Yeah, hi. Actually, first doubt is assignment 11.
Assignment 11. Okay, let me go to that.
11
Hmm. Yeah.
and the ninth question.
Okay, let me see. Ninth question. Okay. Given W 2.5. Yeah, so are you saying why is it close to zero?
Yeah, why is it close to zero? It will explode, no, when
No,
greater than
so
1. Repeated multiplication.
yeah, so at the gradient, so your score is W 2.5, and
Yeah,
so this is the gradient, right? So gradient will be close to zero because this is a sigmoid function that you have, and so you cannot say that the gradient goal becomes
okay, okay.
exactly zero. It does not exactly become zero, it becomes very close to zero because your activation becomes exact very close to one in that sense. Is that clear or
Okay, 1 minute.
do
I think I missed the sigmoid part of it because it's written logistic
yeah.
uh, activation function.
So
Okay.
sigmoid is a class of function and
Yeah,
logistic is that exact function.
yeah. Okay, okay. Yeah, we got it. And the one calculation I'm not getting. The second question.
Same assignment.
Yeah, same assignment, second question.
Okay. Okay. So
You, one by one, like from bottom, if I start, you will be 100 cross 3, 30, sorry, 100 into 30.
100 into sub so it depends how are you using the state vector. You can also concatenate the state vector, right? So you have 130 cross 1, let us say,
Mm.
and then so you will have a parameter. Okay, so output is two-dimensional because it is a one-hot encoding.
That will be, V will be 30 into 2, right?
130 into 2, yes.
And W will be 30 into 30.
So V, okay, let me see.
Yeah,
So you have UX and oh, there are 5 words. Okay, I forgot. So UX and X is your 100 dimensional. So you should be 30 cross 100, right? Because 30 cross 100 into 100,
correct.
that is.
Yeah, 30 cross 100.
So there you have 3000.
Yeah,
And then you have 30 cross 1 state vector, and you have WS transpose. Okay, so um, so let us say you have 30 cross 30, that's
yeah.
900. So 30 cross 100, you have 3000, and now you have 3900. And then you
All
need
the
a bias
biases.
of 30, because each of your vector is of size 30, right?
Yeah, so when that during the W connection,
Mhm.
uh, it is plus 30.
Yes,
And in your output also, it will be plus 2. In your
yes.
wherever that, along with the V parameter,
Hmm.
it is 2. And what about the U?
So we are taking 3000, right?
Correct,
And you will have a bias for each of these.
correct.
So your 30 bias is there.
Yeah,
So your 30 bias is there. So that means you have 3030, and then here you have 930. So 3060. And do we get it? How we get 3006?
no,
3000.
that I got, I mean,
Huh.
whatever you say, but that answer
Mhm.
doesn't match.
Oh, so in the, okay, so then you have
This is what I also did.
uh,
3000 plus 30, 900 plus 30, 60 plus 2. This is what
yeah,
I wrote. And when I add up, it is 4022.
let me check again.
Am I doing anything wrong?
So you have U X W S B. So X is your 100 cross 1. This is 30 cross 100. You have this 30 cross 1. So you have 30 cross 30. This is 30, 3930. And
No, 3030 plus 930.
3030 plus 930, that is 3960.
Yeah, plus
And
62.
why 62?
30 into 2 is your V
Hmm.
parameter will be 30 into 2, right?
B will be okay. Yeah.
Output is 2 and my S is 30.
Hmm.
So it will become 30 into 2 and plus 2 as by 62.
So in the output you will have, so your output size is 2. So you have to go from 30 to 2. Uh,
Is there anywhere like I feel that I don't know, like
I think if I'm
bias somewhere,
missing,
some of the 130 is extra.
Yes, cause so which
And
you are
when I
not
see
adding.
that first,
Uh,
the for one of the first slides,
hmm,
that back propagation through time in that lecture,
hmm,
the first slide only nicely all the dimensions. Of course, bias we were not taking it.
yeah. So so again, which you will have 3000 parameters, with W you will have 900 parameters, and with B you will have again 30 parameters, right?
Yeah,
And then the final layer you will have two, right? So that will give 30 cross 2, 60.
yeah, yeah,
So I think that problem is coming because you're adding bias to U also, right?
yeah. So why you will not have bias?
So the way this, I think the way this calculation is done, they are not they are considering U, W, and B. No
Yeah, but why
biases in
not?
between.
Yeah, but nowhere. I mean, I don't remember, or if anyone else
Hmm.
has
So if
in the
anyone,
class.
yeah, anyone else, do you have anything to say about this? No one? Okay.
And the solution has also not come. I mean,
Hmm.
the working.
Oh, did you not get the solutions here?
No, I mean, we have not got the means the working we have not got. We just know whether our answer is correct or wrong. This is the
Oh,
answer is here. The answer is 3992. That's all
right.
we know. But in that solution sheet, we they show the working full how it
Yes, yes.
comes. Yeah,
Mm-hmm.
that we don't have yet.
Okay, let me see if I have this. Give me a moment.
Yeah, yeah, sure.
So where exactly do they keep the solutions? Can you guide
There
me to?
only, I mean that they just like where left hand side all the
Huh?
uh, just below that there'll be like one more solution will be written. We don't have it here. We
Oh,
have for like earlier ones. If you see for some other week five
oh,
or
okay,
something.
okay, okay. Okay, I see. Yeah, for this it has not been released.
Yeah, it's not yet released.
Mhm. Yeah, for earlier courses also I did not have the solutions.
I think up to a point there we had. After that we have not got.
Uh-huh.
Uh,
Okay.
I mean, the really old ones we have. One we got,
Mm.
but that solution came of some other assign. Means it was not for this year, some previous other year
Oh, okay.
by mistake, some other, but that is not corrected yet.
Oh, this
To
has not
correct.
been done.
Yeah,
Yeah.
that is week 9. It has been going on past 3 weeks, but we've still not got.
Oh, okay.
So some
So there are
corrections are
some
also not
correction.
done
Yeah.
yet. Yeah.
Mm-hmm.
Actually, like I've been raising like couple of doubts in my previous session
Mm-hmm.
also with you. Also, I had raised a doubt
Mm-hmm.
regarding some week two, I guess. Some diagram was that MP neuron diagram was network diagram was not uh,
Oh, yeah. I
matching.
think,
I've not got any like. Is it is it a? I mean, I can these days there are so many mistakes in the
oh,
question of.
yeah, yeah, yeah. The last question, right?
Yeah, yeah, yeah.
Mm-hmm.
That I asked in one of the other TA I asked. So
Okay.
he also felt
Yeah.
that
This
it
is
is incorrect.
ambiguous.
But then in that they are saying no, it is correct only. It is like clear mismatch, and I said that there is a mismatch in the diagram. They said
Yeah.
no, there is no mismatch. I mean, that's the answer I got. Beyond that, then I did not ask anything.
Oh, yeah. I mean, this does not make sense anyway. Yeah, I
It doesn't
remember
make
the
sense.
case.
Like
Yeah.
I clearly work out if you actually work out. So there are a couple of questions like that. Some of the questions they corrected and then they gave marks to all. Others
Mm-hmm.
we are working. mm, I don't know what's happening.
Yeah. So these questions are set by a different set of TAs. So because
Mhm.
if we set the questions, we would have been able to clarify
Yeah,
the doubts. But
but
this
then
this question is done
it
by
should
someone else.
internally. Then I wrote it in one of the feedback also. In the previous feedback, I wrote it.
Yeah.
There is clarity is not there on this
Yeah.
on some other. So
Questions.
still
Hmm.
waiting. Yeah, waiting for the answer.
Yeah.
Somebody has
So
to like take the decision. Yes, it is. So
yeah,
it's
that is true.
internally things are not. Yeah, moving. So I don't.
Because these questions are set by someone else,
Yeah,
and because we are just here
you
for doubt
cannot.
clearance.
Yeah,
Yeah.
so whoever has set it has to go all the way there back and then.
Yeah.
Mm.
So I think after this course there will be a. I think every week you have a
Okay, for
feedback. Hmm. Yeah.
and in this back propagation, after that back propagation only, there was some mm, how it was exploding and vanishing.
Uh, which
Uh,
question?
it's not a question.
Oh, okay.
Um, yeah, if can you just explain? I mean, there was too much of
Oh, okay. You want to?
derivation in that.
Yeah,
Yeah.
yeah. Okay, so then let me share my screen. So meanwhile, I don't know if let me see if it works or not. Are you able to see the screen?
Oh, yeah, I can see. It comes after the back
Mm.
BPTT after when the BPTT starts.
Okay,
I mean, I'll be few
after
slides
this.
after that.
Mm. Yeah, this is PPTT. I think it should
Somewhere
be.
here only. Yeah.
Yeah. You got through all of this, right? Yeah,
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 yeah.
yeah.
Hmm. Okay. So let us start from here. Okay. So ST is a state and SK is a previous state, right? I think, yeah. We are at say S4 and we have to look at say del ST to SK and we have to do it for all that has come before. So that suppose we are at S4, we have to, so there will be this term and then before that S4 with respect to S3, deriving S4 with respect to S2, S1 and S0. So we are looking at that problem right now.
Mm.
Okay.
Yeah,
So
yeah.
yeah, this is what it is written. And yeah, this is a compact form that they've written. Hmm. Okay, so this S comes from applying your W weight matrix and they add a bias. So you
Mm,
have W S J plus P and then some nonlinearity on top of this activation, right?
mm,
And now suppose we do Sj and Sj minus 1. So here you see Sj depends on Aj. So we have Sj with Aj and this Aj depends on Sj minus 1. So this should be Sj minus 1, I guess.
mm,
So that's why we have Sj minus 1 here. Okay. So if we expand it, we have, suppose Sj is your d-dimensional vector. So Aj will be a factor of having d components. So these are the
mm,
d components. And similarly, Sj is just a nonlinear, applying some nonlinearity on Aj. So we apply this nonlinearity element twice. So that is fine. And now if we want to look at this matrix, okay, so because I think you must be aware of this, we are taking a derivation of a vector with respect to
mm,
a vector, and so we'll get d cross d matrix.
mm,
So the derivation of this, or rather derivation of this with respect to this with respect to this, and so on. So
mm.
that is how we fill up this del Sj
Yeah,
by
that.
del
Mm,
Aj. Hmm. Okay, so now, okay, this is what we're doing. Hmm. So, okay. So, yeah, del Sj is basically a nonlinearity. And so this differentiation is basically differentiation of the sigmoid or some nonlinearity that we have here. So then we have the sigma prime Aj and sigma J2, yeah, sigma J2, sigma, okay, sigma. So this is basically sigma AJ1, this line with respect to AJ2. So this
mm,
AJ1 does not depend on AJ2. So these are all zeros.
mm,
You get that right? Okay.
mm,
Hmm. So that means this will be a matrix where you have only non-zero elements on the diagonal and the rest all will be zeros. Yeah, this is what we have. And now we are interested in the magnitude of del Sj by del S if it is small. Okay. Okay. Hmm. So, hmm. So, okay. Del Sj by, so this is my rate of change of Sj with respect to Sj minus 1. And we can write it as, so the size of this, we can write it as the size of this because these two things are equal, right? And now, so this, so there is something called the Cauchy-Schwarz inequality. That is basically, suppose you have a multiplication of two things and that is less than the multiplication of
mm, mm,
norms of the individual things. And now, okay, so this is a bounded function. So by bounded, we, because suppose we're talking about the logistic sigmoid function, so it is between 0 and 1, right? Or
mm,
10 h is between -1 and 1. So
mm,
that means that is bounded. So that means their derivative will also be bounded, right?
Hmm.
Okay, so this is some known bound. So the derivative of, say, if this is a sigmoid or logistic function, the derivative is can at most be 1 by 4. So you
Hmm.
can just derive it and see it can at most be
Hmm.
1 by 4. Okay, and let that be gamma, or if it is 10h, that is at most 1. Fine. So that means in place of this diag of this, you can just say that okay, I have gamma times w.
Hmm. Gamma is, I mean, it's not any other thing.
Gamma
It
can
is
be,
just
yeah,
replaced it with that.
yeah. So depending on what type of sigma you are using, you will have different forms of gamma. So just for any general function, let us say it is gamma. So if it is say 10h you are using, then you can just say gamma equal to 1 or something else.
Hmm.
And they are saying that this w, so what's this w? Yeah, this w matrix is also bounded. Let us
Hmm.
say the size of w is at most lambda, right? And so again we have this connection like we saw, the
Hmm.
dependency on each of the previous states. And because we are able to see that for any j and j minus 1 it is bounded by gamma lambda, so it will just be a multiplication of all of these terms.
Hmm.
And so okay, so this is a multiplication, so you have to go from say k plus 1 to t, because that is so j st to say st minus k. So you
Hmm.
will have at most t minus k terms. So this will be just a multiplication of those terms, t minus k multiplications. Okay. So okay. So now the rate of change of st with any k depends on this product that we have here.
Hmm.
And if it is small, say 0.5.
Hmm.
So if you take powers of 0.5, it will continue vanishing, right? So it will have 0.5, 0.25,
So this
then
is a concept that is used in that question. Yeah, the question that I asked, like whether it will at T22, state 22, what will be the gradient will,
oh, okay, yes, 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 yes. So it will not become exactly zero. It will, you may just have say 0.000000001 or something like that. Very small, but not exactly zero. Because this thing, even if you have a very small number, say 0.1 here, it will not become exactly zero. You will
mm,
have say 1 e raised to the power maybe minus 100 or something, but still not zero. It will become close to zero.
yeah, but
So hmm,
in our case, uh, this is not less than 1, it is greater than 1.
yeah, so
So
suppose it is
phi
greater
is
than
greater
1.
than 1, right?
Hmm. So it will explode. Say if your t is large, you are looking at a large document or something,
Yeah.
and say this is say
So
100.
how will
So
the answer then, the gradient will, okay, okay,
like,
okay, okay, when the it is,
so if this
when it is,
increases, this will increase. This gradient will increase, right?
the gradient will explode.
Yeah. So
And
so
then
because
suppose the gradient is not exploding, it is uh, diminishing, no? It's almost vanishing, no? The answer is
oh
saying it's close to zero.
oh for that question, yeah. For there, your yeah there it was.
Getting confused, I guess.
Oh, there they give this W. They gave this as 2.5, right?
Yeah.
But the logistic, but they use a logistic function. So gamma was your 1 by 4. So so gamma lambda is 2.5 by 4, which is 0.6 or something,
Okay,
which
like
is
that. Okay.
less than 1, right? And so it will vanish, but not
Oh,
become zero.
okay. Oh,
So yeah, so this vanishing and this exploding or vanishing condition will depend on what type of sigma you're using, and also what is the weight matrix that you have.
okay. Oh, okay. Thank you.
Okay. So anyone, any other question? So this is the last session again. So if you have any question from a previous lecture, you can also discuss though, not necessarily this week. I mean, other sessions will be there from tomorrow or till 16. There may be a few other sessions, but I
So,
think
you'll cross-check this second question, that bias thing.
okay. The
Yeah, you can.
3000 thing, yeah.
Yeah, you can respond later, and
Yeah, let
also
me
you can just
check.
check for that, and then yeah,
Hmm.
because no one else raised any doubt for this question. So I'm
Mm-hmm.
wondering, like, where am I going wrong?
So if you look at the, because the way they are doing here, they are not adding any biases to U
Yeah,
itself. They are just using
yeah,
WX plus B.
yeah, but all
Mm.
the other biases are added.
Yeah.
So,
So they have this equation somewhere here, right?
yeah. Mm,
Yeah, this one, right? Mm. So here you get 3000, here you get 300, no, how much you get? 3000, 900, because 30 cross 30, 3900, and then you have
yeah, they have.
3930.
Yeah, they have added here bias.
Yeah. Oh, 3930, and oh, you also have this fee here. So
Yeah,
fee goes from
36.
32 to 60.
Mm, mm.
So okay, so then it works out, right?
How?
So you have 3000 here. You, for
Can you
you
just
have,
expand one only single slide? I mean, it's too small to see.
oh, okay, okay, okay,
Yeah,
sorry.
yeah. Okay, it's
Ah,
better.
oh, it became too big. Okay. Okay, my system actually froze.
I can see.
Yeah, my, okay. So there is, my system actually froze.
Oh,
Let me connect.
but I can hear you. Okay.
Give me a minute.
Yeah, yeah, sure.
Okay, now it should. Yeah. So here for you, you have 3000, right? 30 into 100.
Yeah.
And so here you have 30 cross 30, which is 900, so 3900, and B has 30, so you have 3930, and then
Mm.
you come here V will go from 30 to, so your output space has two this thing, two outputs that you want. So you have a 30 cross 2 matrix there, that is 60.
Yeah.
So earlier you had 3930 and 60, which is 3990. And for C, so you will have two biases on the output layer. So that gives 3992.
Yeah. So they have considered only
Yeah, no
the
biases for you.
no
So
bias. Okay.
yeah,
Okay.
so biases are added only, I mean, there is only one bias for SI uh,
Um,
inside
o-
sigma of SI. So that, I think this is the form that
okay.
they're considering.
Okay. Okay.
Okay.
Thank you.
Okay, any other questions? I wanted to show.
Hello,
Yeah, hi.
sir. Hi,
Yeah,
sir.
yeah.
Sir,
Hi,
I
hi.
am having the solution for 11th second, week 11 second question. That is 3992.
Yes, sure.
So I calculated that and the answer is 3992 and I think it is correct.
Yes.
I
So I
can
think,
share that chat box.
yeah, you can, if you have, yeah, you can share, if you have a picture or something, you can share it there. So the assumption, yeah, you can share it there. So you will only have to consider one bias here, but I think that is the condition or assumption that we are not making. Yeah, you can share the solution in the chat box. Yeah, this is correct. Yeah. S- Okay. Okay. Any other questions? I was looking if there were any encoder decoder type tutorials available, but I was unable to get a collab notebook for that. But I will share. Okay, I'll share a GitHub link. But the thing is, this may not be possible to work on your. It may not work on your system because you need a lot of memory for running this. Uh, so this is a image captioning problem. So basically, you give an image and say what that image is doing. So you must have seen examples like this in class, uh, where say there was this example of a man throwing a frisbee, and the task was to describe that image. So this set of code works in that sense. So one thing you can do is you can paste this code in Colab and then run. So then it will be fine. But it may not be possible to run this on your local system if you don't have a good GPU or a good RAM. So, but you can still go through the code and run it on Colab. It will be uh, a bit of a task to paste it in Colab, so function by some function, but after you can work on that. Okay, any other questions from previous weeks? Any other concepts you'd like to discuss? So even after the, finish after this course finishes, uh, try to look through PyTorch, the great set of tutorials. Try to go through those tutorials, and then there are a lot of GitHub repositories available where you can just clone and then work on it. The only issue being that it may not be possible to run those on your local system. So try to search for Colab notebooks in that case. So once just get started on any problem, and then yeah, you can try out your ideas once you understand what that problem is doing. So the most interesting problem comes in this encoder decoder type of problems. You can just match anything you want to do. You can also go for say text to speech type of thing. You can download a speech data set somewhere and then try to see if you can uh, get say LSTM and RNN to get the encodings of that text and that speech, and then have a text for that. So you can try those out if you have time. Yeah, again, for those joining now, if you have any doubts regarding the previous lectures, we can discuss those.